Hi, I'm Sajid and today I will be talking about sentiment classification using BERT. So we will be using financial data, and that data will have different reviews or statements, and then there will be three labels. There will be basically one label, but it will have three classes. So it will have neutral, positive and negative reviews, or you can say statement or sentiments. So we will be using transfer learning on a BERT model. So in this video we will discuss the basic structure of a BERT model, and then we will learn that how we can download the data from a Google Drive, and then we will learn about the pre-processing steps of a BERT, and then we will use transfer learning to train our own model on the top of basic BERT model, and then we will evaluate the BERT our trained model on our data, on test data, and finally we will be able to predict the sentiment on raw text using our trained model. So about BERT is a model that is based on encoding architecture, and it works on transformers, and it's a bidirectional architecture, and so basically it works on the transformers. I won't go into details that how transformers work, but here you can read about the theoretical part in these papers. This is a paper for BERT, and this is the paper about attention or about transformers. So the first step is that we will do the installations, and this step is optional. If we have already installed the libraries which I am installing now, you can skip this part, but I am assuming that you haven't installed these libraries yet, so I have just added this part. Other than this, you need some more libraries. Let me check. Okay, so let's install these libraries, and then later on if we need some other library we will install at that time. So since I have already installed these libraries, so it won't take time on my PC, on my laptop. Now let me see the versions of different libraries. So here you can see the versions of different libraries, and it's better that you follow the same versions, you install the same versions which I have. Now the second step is to import the libraries which we will need in the process. Now I will add some configuration settings. So I have CUDA installed. It means that I have a GPU in this laptop, but I was getting some memory error. So instead of a GPU, I will use simply a CPU here. So no, I am getting I got this data from this paper, or from, you can also get this data from this paper or from this link, but I have also attached the dataset in my Google Drive. I have saved in my Google Drive, and you can use that link to download the data. So you can also learn that how you can download the data using some Google Drive link. So this code will check if this file already exists, it will just pass, otherwise it will download the data from the Google Drive. Okay, it's done. Now I can read, I can save this CSV file in a data frame. So I can see the columns. So here the one problem is that this CSV or this data frame has no column names, so we have to assign column names here. So before assigning the column names, we have to remove the columns having none values. So here df dot, what's the syntax? Okay, let me check. Yeah, I think it is drop any. So here we should df equal to, let me check. Okay, so now we have two columns. Now we can rename these two columns, not rename because we don't have the names here, so we can add the names of the columns here. So it will be df dot columns equal to, what column name should I give? Sentiment and statement. Okay, so the first column name should be sentiment and statement. Now you can see that now we have two columns. The first column is sentiment and the second column is statement. Now we have around 4,845 samples. 85 samples in both the in for the both columns, and you can see that we don't have any null values because the total number of samples are 4845, and each of those columns have values of or rows of 4845. It means they are not null. It means there is no null value in these two columns, so we don't have to use any missing value algorithm here. Now if I want to see the class distribution, I can use some plot here. I'm getting some issue in the plot of class distribution, so instead of plot I will just show using another approach. So here I can use counter library. Let me check the class distribution. Counter count counter. So here you can see that we have, for neutral we have around 2878 samples, and for negative we have 604 samples, and for positive we have 1363 samples. So it's a sort of imbalanced data set, but since the purpose of this tutorial is just to show how we can implement BERT, so we won't go into the algorithm of balancing the data set, or so I will just move on. So now since we have already checked the data, now the first step in any machine learning project is to encode the categorical variables, because you know that machine learning or deep learning models cannot take the strings values or images or some other format of data, so we have to convert it into some numeric format. So we have to do encoding, and here I will be doing label encoding for the sentiment. So now you can see that we have another column for the label encoding of sentiment. Now for BERT we need some specific data pre-processing. So when we need to feed our data to BERT, we have to specify the start of a sentence and end of a sentence, and then we have to give specific length of a sequence to the BERT model. So here the first step will be to do the tokenization, and for tokenization we have two options. One is that we can use BERT case base, and the other is uncased. In the case base we don't change the case of the characters, while in uncase we can either use the lowercase or uppercase. We can convert our variables or letters into uppercase or lowercase. So here I will be using BERT base cased. So we will be using BERT tokenizer here. Now if you want to check that how a tokenizer will work on some sample text, you can check it on any text. Let's suppose this is a text, and if you want to see that how tokens will look after, how we can split the whole text into BERT tokens, let me show you. So this is how tokens will look alike if we give a sentence to a BERT tokenizer. So you can see the different tokens and then different IDs assigned to these tokens. Now we have to assign special tokens to our data. So the first is, as I told you, that the first is separator. So we have to mark the ending of a sentence using this token. Similarly, we have to add token about the start of a sentence. And then we have token for the padding. And then we also have tokens for unknown, like if we have some words that are not in the vocabulary, that will be in the unknown or tokens. So we have specific tokens for these. So for the end of a sentence, the token ID will be this. Similarly, for start, token ID will be this. For padding, token ID will be 0, and for unknown, the token ID will be 100. So whenever you will see 100, it means the tokens are unknown, or whenever you will see 0, it means that this is the token for padding, or this is the token ID for padding. Now all of this can be done using encode plus. So I will just give you an example here. So let's suppose we want to fix the sequence length to maybe 12, and let's see that how our text will look like. Let's test for any of the sample value here. So here you can see that wherever there is 1, it means there was some text or some word, and wherever there is 0, it means it was padded token. Now one parameter which we need to give to BERT is the sequence length, because BERT works on it works on a fixed length. We cannot give words with variable, we cannot give sentences with variable sequence length, so we have to give a specific sequence length here. So let's see that which sequence length we should give in our scenario or in our data set. So you can see that our data set has maximum, like the maximum length of our data set for any sample is around, like it is less than 100 or maybe less than, I think, 75. So here we can choose any sequence length of our own choice. So I will maybe here I will choose 75 or 76. You can also choose some other value. So you can see that most of the reviews are having a length around maybe 25 or 30, but to be on safe side I will choose a length of 72. Now we need to prepare our data to be fed to our BERT model. So we have certain steps here. We can define a class. So in this class we will pass the reviews, or you can say reviews or the text, and the targets, which are the sentiments, and then the max length and the tokenizer. Now the next step is that we will divide our data into training, testing and validation. So here in the first line you can see that we are dividing our data into training and testing. So we are using 90% data for training and then 10% for testing, but then again out of those 10% samples we are using 50% for validation. So we have 90% data for training, 5% for validation, and 5% for testing. If you want to see the shape of the data, then the train has 4360 samples, and then validation has 242 samples, and test data has 243 samples. So here we will create a function for data loading. You can choose any batch size. Here I am choosing 16, but you can choose depending on your RAM or memory of your system. Now there are a lot of helper functions or helper models that you can use, but we will be using basic model of BERT. So we will be using basic model of BERT, of pre-trained model of BERT, and then we will be using transfer learning to train the model on our own data set. If you want to check the parameters, how many hidden layers are there, then you can check using so we have 768 hidden units or hidden nodes in a BERT, this model of BERT. And now we can define a class to predict now we can define a model here in a class. So here you can see that the first model, on the first layer we are using the pre-trained BERT model, and then we are adding a dropout layer. Dropout layer is used to remove the overfitting or to compensate for the overfitting. Now in this class we have to pass the number of classes, and here okay, we have to define the class names. So let me define the class names here. So if you have a GPU, so you can move the data to GPU here in batches. And then we will be using softmax for getting the predictions. Now we will start a training. So I will be training using 10 epochs. For the batch size, you can choose any batch size, like you can choose 4, 8, 16, 32, 64, and then so you can tune these hyperparameters as per your requirements. So we'll create helper function here to save the losses and uh, other parameters which we will need. Now let's write another function for the evaluation. And here we will just initiate empty list for training and validation accuracy. Now this is the function, this is the code which I am writing for the training, but on my laptop it will take more than maybe an hour or 2 hours. So I won't run the code here, but I will show you that how it will look alike. Let me show. I've already trained this model, and so here after I run this cell I will get something like this. So I will also get the curves training and accuracy on training and validation data. So you can see that we got around uh, our training accuracy is almost touching 1 or 100%, while our validation accuracy is above 85%. So I won't run the code here for the training, but I will add this code and these graphs in my GitHub repository, and you will be able to run the same code on your PC. But here I will use the I will use the saved model. Instead of training, I will just use the model which was saved earlier. So since now we have loaded the save model, now we will do the evaluation on our data. So we will be doing the testing on test data, not on the validation data. So it is taking some time. I will pause the video here and I will come back after once it is done with the evaluation part. Now evaluation on the test data is complete, and you can see that we got an accuracy of around 83%. And we can say that our model is generalized well, because if you remember, our validation accuracy was also around this number, like it was around 80 or 85. So since test accuracy is almost close to the validation accuracy, so our model is doing well in terms of generalization. Now I will write a helper function that will be used to get the predictions for our test data. So I will just copy the code from my notebook. So this is the code. So this code will take a data loader and a model. So that model will like the model which we have already trained, and then from that model it will take from that data loader, it will take each review, and then it will give the predictions against that review. Now here you can see that it is taking the review, and then it is taking like it is getting the IDs, input IDs, and then for the outputs it will predict the it will get the probabilities, and then from the probability it will get the class, and it will return all these in the output of the function. It will return the predictions, the prediction probabilities, the real values, and the review text. So here I will just run it, and we will call it. So now we are passing the model and test data loader. So test data loader will pass the test data, and in return we will get all this, like we will get the y predictions, then we will get the all we will get the probabilities, we will get the y review text. So let me run this. Meanwhile it is running, uh, let me write copy the code for classification report. Okay, so it has completed. Now for the classification report, you can see that we are getting precision, recall, and F1 score for all these three classes. So our model's doing pretty well here, because precision is for negative precision is 0.90, then 0.87 for neutral, and then for positive it is a bit low, but still it is acceptable. Similarly for F1 score, uh, the negative has the highest F1 score, and then the neutral, and then the positive. And overall accuracy is around 0.82 on the test data. So now we will also write a code for confusion matrix. I will just copy the code for confusion matrix here. So this is a confusion matrix for all these three classes: negative, neutral, and positive. So now let's see that how, if you want to see that how it is performing on our test data, like you have already seen using performance matrices, but if you want to see on some single sample, we can also do this. So let me copy the code. Instead of 2, so I'm taking this data from our test data, so I'm just passing the index, and here instead of 2 you can pass any other number. So if I want to check that what's inside the review text, I can simply check it. So review text is basically, so this is the text, review text, against which we will be checking the predictions or output. So we are here, we are giving the true or the ground truth value of the label. So the true sentiment is positive. So this is the review text and this is the output. Now we will test it, and now we'll see that what our model is predicting against this review or statement. So you can see here that the probability of positive review is maximum or 1. So model is almost 100% sure that this is a positive review or statement. So you can see that our model is working well on even on the testing data. And you should know that testing data is always unseen data to a model. We use training data and validation data for the training, but testing is not used during the training process. Okay, so now we can also do the prediction on raw text. So let's suppose this is the raw text, and you know that whenever we give a raw text, it has to pass through the whole pipeline, right? So we'll pass it through different steps. So the first step will be, it will pass through encoder, and then that encoded message or encoded text will be passed to train model, and then our model should be able to predict the class. So now you can see that this was the raw text or the message which we passed, and this is the sentiment. So from the message you can see that the rapidly increasing cost. So you can see from the message that it is a negative text or negative review, and model is predicting it well. So this is how you can see that our model is predicting, is giving good predictions on raw text, uh, on text that was not even in the test data set. Although test data is also unseen data, but just for your satisfaction, I just put some raw text. So this is about what we did here today, that we got the basic understanding of BERT. I didn't get into details of theoretical into theory, that how it works. For this you can read papers, or maybe I can make another video on the basics of BERT or theoretical part of BERT. And then we see then we go we went through a different pre-processing steps like tokenization, masking, padding, some special tokens, and then we went through the transfer learning part. We got a base model of BERT, and then on the top of that base model, we did transfer learning for our own data set. and we use Hugging Face library, and then we evaluated the model on test data, and we also got prediction on some raw text. So I hope that you will be able to execute this code, and if you get any issue, any errors in this code, or if you get any issue in installations, then you can definitely ask me in the comment section, or you can email me. Thank you for your time.